Okay, hi everybody. Today we're going to work on section 5.5. Write that down in your notebook, please. Which has to do with identifying proportional and non-proportional relationships in tables and graphs. Describe a proportional relationship using an equation. So we're going to talk about what's proportional and some other vocabulary words before we even do this section. So, vocabulary. First vocabulary word is you need to know what proportional is. Two quantities that have a constant ratio or rate. So they have to have the same ratio between all the things that are going on. And then we call that a proportional relationship. For example, say you're babysitting. You charge $5 every hour. That would be a proportional relationship. If you charge $5 for the first hour, then $10 for the next hour, then $30 for the third hour, and so on, that would not be proportional. Okay. A constant of proportionality is the constant ratio. So in my first example, the babysitting, it's $5 every hour. That would be the constant of proportionality. Okay, so how much each hour? That's your unit rate. Non-proportional are two quantities that do not have a constant ratio or rate. Okay, so these are the words we're going to be using. I need to see that you're using them in your answers. And you need to know the difference between proportional, non-proportional, and what I'm talking about for the constant of proportionality. Okay, so part one, identifying proportional relationships. Directions, determine whether each relationship is proportional. If it is, identify the constant of proportionality and explain your reasoning. So if it's not, you basically just stop. If it is, you identify the constant of proportionality. So, here's our first one. Determine whether the number of legs are proportional to the number of spiders. So what you're going to do, the work that you're going to show, hopefully you're writing all this down, is you're going to compare. They're asking you to do the legs to the number of spiders. So the order in which they give it to you is important because that's how you're going to find if they're proportional. Legs to spiders. So the first one, as a ratio, which is a fraction, is 8 to 1. 8 to 1. The next one, legs to spiders, is 16 to 2. The next one is 24 to 3. And the next one is 32 to 4. Now, if you simplify each one of these, this equals 8. 16 divided by 2 is 8. 24 divided by 3 is 8. 34 divided by 4, 32 divided by 4 is 8. These are all equal. So this is a proportional relationship. So it's proportional. Okay. The proportionality, the constant of proportionality would be 8 to 1. So this is the first answer. The second answer is 8 to 1. And the third answer, it says, explain your reasoning. This means that there are 8 legs, so I'm using my first thing, 8 legs for every spider. So my explanation is that there are 8 legs. There are 8 legs for every spider. And that's your explanation. Okay, let's try another one, and then you can do one on your own. Determine whether the cost of baseballs is proportional to the number of baseballs. So we're doing cost to the number. So cost is going to go on top, the number is going to go on the bottom. Okay. So I have 2 to 1, cost to number of baseballs. 3 to 2. I have 4 to 3. So $4 for 3 baseballs. $5 for 4 baseballs. If I look at this, this means $2 per baseball for the first one. This means $3 for 2 baseballs. That's not equivalent to $2 per baseball. These are not equal. Okay? This would be $1.50 per baseball. And you would simplify each one. They are not equal. is not a proportional relationship. It's not proportional. So, that is it. We do not need to explain it. We do not need to write a constant of proportionality because there are none. Alright, yours is the last one to try. Determine whether the number of meters is proportional to the number of seconds. So you're doing meters per second. Write down the table, determine if it is proportional, and then if it is, give me the constant of proportionality and explain it. Alright, moving along. Part 2. Use proportional relationships to write equations. Now, this is the general kind of equation that you're going to be using. Y and X are the things that you're comparing, and X is your constant of proportionality. So what it's generally increasing by. There should be some form of a constant going on. Okay. Nina charges $34.50 for 6 days of pet sitting. Find the constant of proportionality. So we want to know, part 1, the constant. So the first answer, I'm going to do number 1. We do $34.50 divided by 6, because that'll tell you how much for 1 day. Since the constant of proportionality is a unit rate, $34.50 divided by 6. I'm showing my work. 34.5 divided by 6 tells me it's $5.75 per day. So that is the constant of proportionality. Then write an equation relating the cost of pet sitting to the number of days. Okay, so back to that general equation. This goes in for the K, which is our constant. And they're saying, write an equation relating the cost. So the cost is equal to, C for cost, is equal to $5.75 times each day. Okay? That's my equation. I don't need to use Y and X. I'm going to use variables that make sense in my problem. Cost for C for cost and D for days. That's question number 2, writing the equation. Okay, third question. What would be the cost of pet sitting for 4 days? So now we're going to use our equation, and I'm going to plug 4 days in for D. So the cost will equal $5.75 times 4. Type that into my calculator, and I get that the cost will be $23. And that's it. So first I found my constant of proportionality, then I wrote my equation with variables that relate to the problem, and then I found my answer. Okay, you're going to try one on your own. Copy this all down. There's 3 questions within it. Make sure you answer all 3 questions. And that is it for tonight. Have a good one.